Hello, everyone. This is Kamesh Pemaraju from Platform 9, welcoming you all to our webinar for today. We'll just give about 30 seconds for everybody to join the webinar. Our topic today is operating Kubernetes in real-life production environments and the life cycle and maintenance considerations. So we'll just start in about 30 seconds. All right, let's get started, folks. Once again, welcome. Good morning, good afternoon, good evening, wherever you're dialing in from. We're pleased to host our 7th in the series of our webinar series here that we've been doing for the last several months. We have covered a lot of different areas of Kubernetes in production and the journey to it. Today, we're pleased to have a special guest, which who we'll be introducing in a second. But again, the subject of today's webinar is lifecycle and maintenance considerations. So if we go to the next slide, Peter. As always, we'll kick it off with introductions and also remind you of our special gift and present that we give away at the end of the webinar. So we encourage you to stay through the end of the webinar to know if you are the lucky winner for today. As always, Peter is going to give us a quick recap of the journey to Kubernetes. And as we have been saying throughout the webinar series, the journey into production is fraught with a lot of challenges, lots of considerations, and we've covered a lot of those over the period of 6 months. Today, we'll kind of cap it up with how do you keep this thing up and running in production? What are the challenges you have to deal with as you do that? And for that, we have today a fireside chat, as we always do, with Gautam. So if you could go to the next slide. Real quick reminder before we introduce our guest. We have a drawing today, as always. We appreciate you joining us. We'll give away the online Kubernetes course from our learning partner, LearnK8s, and we will announce that at the end of the session. And there's a giveaway for every session, so we'd love you to come and join us and learn about Kubernetes in production and the journey to it. Next slide, please. So the speakers in the agenda, as always, Peter is here. We'll let Peter introduce himself, but specifically, I'd like to extend a warm welcome to Gautam. He's our Director of DevOps at Platform 9. Lots of real-world experience with running Kubernetes in production for our customers at fairly large scale. So this will be a very interesting conversation as he has lots of wisdom to share with us. So with that, I'm going to let Peter and Gautam kind of introduce themselves and maybe talk a little bit about their journey and their background. Over to you, Peter.
Sounds great. Hi, everybody. My name is Peter Frey. I am the field CTO here at Platform 9 Systems. I manage our pre-sales team as well as our customer success and onboarding teams here at Platform 9 Systems. I've been with Platform 9 for about 3.5 years now, and I'm presenting to you today from sunny Florida. As part of my role, I really get a unique perspective on what's happening in the industry with Kubernetes. I get to talk to our customers on a quarterly basis, all of them, and I get to talk to all of our prospects very frequently on a day-to-day basis. And so I get a good sense on what's happening in the industry and what are some common themes that our customers and enterprises are going through. And so I'll talk to you a little bit about that on the journey to Kubernetes and what I'm seeing are common threads. And then we'll jump into the sort of the focus of what today's conversation is about, which is really what happens after you've got your Kubernetes cluster in production. What happens on day 2, and what are some of the challenges there? And we'll get into that. Gautam, you want to say hi?
Yeah. Hey, everyone. I'm Gautam Jayaprakash. I lead the DevOps team here. So what my team does here is really manage the lifecycle of our software in production. So, getting code from a developer's machine to all the way through to production, making sure it stays up, is the charter for the team, and as part of doing that, we manage a whole variety of infrastructure, Kubernetes being central to it. And we've gone through quite a journey ourselves in the last 5 years that I've been here, and I'm excited to be talking about that with you guys.
Thanks, Gautam. So I'll jump in sort of on the next steps here. I wanted to talk about that journey to Kubernetes because, oh, excuse me. Our customers, our prospects, it seems like everybody I talk to is on some form of Kubernetes adoption journey, right? And whether I'm talking to enterprise architects, whether I'm talking to CTOs, whether I'm talking to developers, in every organization, East Coast, West Coast, Central, in Europe, down under, everywhere, our customers are adopting Kubernetes. And as soon as they make that decision to, take a peek at Kubernetes to try to determine what does Kubernetes mean to our organization, that's when they start doing different things. They start Googling around, like, well, I'd like to get a first Kubernetes cluster. How do I do that? How do I install it? Do I want to use a cloud provider? Do I want to do it, on-prem? And they start trying to figure this Kubernetes thing out, right? And eventually they land on something. Maybe it's a AWS Kubernetes cluster. Maybe it's using kubeadm and deployed on VMs or something like that. But they get this Kubernetes cluster up and they've made decisions, right? They followed some tutorial. They've picked a CNI, so they have some networking configured inside of there. And, CNI is a whole topic, right? And how to do different things right there. But, as they're going through this thing, they get this initial Kubernetes cluster up and running. Then they deploy their first application. And it's always, the hello world of Kubernetes, or maybe it's the Nginx. Personally, I use Nginx when I did it because then I wanted to explore ingress controllers. But those are the most common two. And then the customers are going, okay, well, what's next? I've got my Kubernetes cluster. I've got an app. It seems to be functioning. What does this mean in my organization? So as they're going down this journey, they say, okay, hello world's great, but I need something a little bit more complex. I mean, so many customers have deployed WordPress as one of their first applications. It's kind of scary, right? And most of them fail almost immediately, right? They do Helm install and then they deploy WordPress, and that deploys multiple containers, and one of those is a storage container, and that storage container requires persistent storage, and it immediately breaks. And then they go, well, what is persistent storage in Kubernetes, and how do I do persistent storage in Kubernetes? And they Google around on exactly that. What is CSI? How do I apply a CSI driver? And then they usually settle on something that's easy, like host path. And then they get WordPress up and running and they're feeling pretty good. So the next step that I commonly see is that the customers are then starting to say, well, what's my first corporate application that we can deploy? It's usually not a money revenue critical application. It's usually a tier D, if it dies, nobody cares, right? But it is a production app that does get some use, and they try with that. Then they start looking at, well, how is it deployed? Is it deployed in Docker today? Do I have a Docker file? How do I write those things if not, right? And they do Googling around on that, and then they start figuring out, okay, I've got it in Docker, and I can sort of get it running with this YAML file in Kubernetes. And so we get that app and we start to deploy it. As soon as that's deployed, right? And maybe it requires persistent storage, maybe it requires internet access, maybe it requires a specific ingress. There's a lot of complexity there, right? But now the people that are on this journey are starting to figure it out, right? That if we're going to production with Kubernetes, I have to monitor my apps. I have to know they're up. I have to know that they're healthy, right? And doing that in a Kubernetes world is a little bit different than doing it in the VM world or physical server world, right? So again, right back to the Google machine, our customers start talking about, looking at Datadog or Googling around, we find there's Datadog and Prometheus and Grafana and Alert Manager and many other things in the monitoring space. I think a lot of our customers end with Prometheus, Grafana, or Alert Manager combination. They follow a tutorial and they deploy that, right? And then they realize that it requires persistent storage, and then they maybe they have to go back redeploy the cluster because they didn't do persistent storage sort of the way they want to with a default storage class and that sort of thing. So maybe this is an iterative process to go back, redeploy the cluster as they get smarter and do different things. And ultimately, they have their app, they have Kubernetes up and running, they have persistent storage, they have their CNI, they've got monitoring, they've got Prometheus looking at Kubernetes metrics, they've got Grafana for a dashboarding, they've got Alert Manager, they're getting Slack messages when there's problems, right? They're feeling pretty good about that. Then they need to figure out, well, how do I do logging, right? Because logging in Kubernetes is also different, right? If a Kubernetes pod moves from one worker node to another worker node, what happens there, right? So then we start looking at, how do I capture the logs? Kubernetes provides logs for pods n-1, but if pods move or they're cycling or containers are cycling, it could be easy to lose things. And if they move from machine to machine, how do you correlate the fact that it's the same pod, but it was once on this machine, now it's on this machine? So they start Googling that. And by the way, they realize they need persistent storage here as well. They need to figure out, do I want to use Loki? Do I want to use the ELK stack, Elastic, Kibana, that sort of thing, or Influent Bit, right? The EFK stack. They pick one, they follow the tutorial, they get that up and running, they're collecting logs, and then they move on from this process, right? And we're getting to the point of what where we're going to talk about specifically today. But then they're starting to look at, well, how do I do a CI/CD environment? Continuous integration, continuous deployment. Do I need to use a Jenkins X or a Spinnaker, these cloud native tools that are very popular for this kind of environment? Or can I use my existing Jenkins? And I think Gautam's going to tell us about some of the ways he deploys applications here in a little bit. So this will be an interesting discussion. And then how do we do EAB deployments? If I've got a new microservice, I just upgraded to version 4 of the microservice, how do I route some of my traffic over there? How do I say, hey, all my QA developers log into the system. When they hit the URL, they're going to the QA environment, and they can test and do things kind of in a live environment. But all my real customers are coming in and going into the 3.0 version because the 4.0 hasn't been promoted to production yet. And then that's a Google project. They start realizing that Istio and Linkerd are big projects, and they're heavy, and they're challenging to deploy, and sidecars and lots of complexity there. So I find that a lot of our customers skip this step, right? They come back to it, but for their initial kind of deployments, they skip the AB deployment part of it and go right into, how do I get into production? If at some point information security gets involved, right? I think we'll have some conversations with Gautam on this as well. How do you do identity management in your production clusters, right? Who has access to starting and stopping and pods inside of a production cluster, right? Do you have PCI data? Is it defined in red and green zones so that you can know that your data in flight and data at rest is encrypted? How do you do that, right? And they start asking a lot of questions, and they go through their checkbox before you can actually deploy into a production environment. So then they're starting to think, okay, we've got Kubernetes, we've got a way of repeatedly deploy this, security has blessed this, and we're ready to go into production. And that's when the SREs get involved, and people like Gautam and his team start thinking about, well, day 2, what is day 2 operations? What do I do on day 2? How do I keep my Kubernetes cluster healthy? How do I manage upgrades, right? From Kubernetes has 4 releases per year. How do I keep up with that rate of change? Do I want to keep up with that rate of change? Are my applications blessed for the latest version of Kubernetes if I do upgrade it? Has it been tested in pre-production environments? All kinds of stuff happens in this day 2 environment. And this is really going to be the focus of what happens for this conversation today. Okay. And then, customers are starting to think that they're ready. Maybe they go through some production outages and they get some learnings on, a worker node goes offline, pods move around, logs are getting mixed up between different machines. We can't SSH into the worker node because the CPU is hosed or locked, right? There's no access to the environment. How do I troubleshoot this, and how do I do that? All of this, the day 2 operations, the production outage are good examples of what happens when you go into production. So real quickly, I'll highlight this. Most organizations I see are looking for some form of Kubernetes managed service. The reason that they're looking for that is because finding Kubernetes talent today is hard. Kubernetes talent when you do find them, they're expensive, right? And they want to work at the best, companies, right? So, for a small startup somewhere, you might find it hard to attract the best talent, right? So they're looking for some way of simplifying the deployment of Kubernetes, simplifying simple decisions when it comes to monitoring, logging, the CSI, the CNI, CI/CD stuff, right? And they're looking for a world-class support system, right? The companies that's been there, that's done that, that's seen these kind of outages, right? And they're looking for SLAs. And that's a lot of what Platform 9 offers. I'll give you a little commercial on that later, but we're going to get into sort of the fireside chat. This is our 7th webinar of this series, where we talked about networking and CSI and all kinds of different challenges. I encourage people to go back and look at some of those recordings. But for this purposes, I think right now I'd like to jump in with Gotham. Gotham, as we're starting to think about day 2 operations and keeping Kubernetes clusters performant, what are some of the main topics that you find are day 2 operations? What does it mean? What is day 2 operations to you from a DevOps perspective?
From a DevOps perspective, there's several things. I think when you talk about monitoring and making sure your application is up, you have to start with your SLA. I mean, there's a very good book written by folks at Google on SRE practices, and they talk a lot about various concepts on how to construct that SLA from service level objectives and track service level indicators and all of those things. But essentially, you need to have a notion of uptime. We need to know, for every application that we've deployed for a customer, is it up or down? That's kind of ground zero. Getting to there is, while that sounds simple, is can be surprisingly hard. We have several deployments of our services. We ourselves started from a VM-based deployment background to move to Kubernetes. There's still some of that legacy infrastructure. We also have we have to have a notion of, is the underlying infrastructure up? Is each customer up? What is the error rate on their environment? And basically tie all that into a metric and a set of alerts that you can track to ensure your customers' user experience. So all of this, again, the reason we have an SLA is because we want to guarantee a consistent user experience to our customers. And to do that, one of the big things that we had to do was have a monitoring system that can handle these various environments that we have, whether it's on-prem Kubernetes clusters in the public cloud, using, for example, Spot instances in AWS. We need to make sure that we had, we use tools like Cortex to kind of aggregate metrics from these various sources and present them in a single interface. And we want to make sure that we have all of the measurements we need to track production. Once you have that, an equally important part of it is kind of what Peter alluded to, is having a world-class team in place that can operate these Kubernetes clusters. And by operate, it's not just, oh, something broke, I know how to debug this, but it's also making sure you have the right runbooks to track common failures, to reduce your turnaround time. Once you have a standard runbook procedure, how do you automate it? Putting all of that work in place is non-trivial and is a big part of what the team does here. So I think it's a question of gathering the data and then having the team in place that knows what to do with it is probably the biggest part of day 2 operations.
So Gotham, you went straight to the apps and straight to the SLA, and that's kind of the holy grail, right? Mm-hmm. And you mentioned some of the steps. You have to manage the OS, you have to manage the infrastructure, you have to manage Kubernetes. you have to manage your monitoring environment, Prometheus and Grafana. You mentioned Cortex, which is another component. This represents a vast skill set, right? I imagine your team. What can you tell us about your team? Like, you have a number of Kubernetes experts, CKAs. I know you have those. You have infrastructure guys. You have Prometheus guys. What does it look like from a team perspective to manage Kubernetes in production?
Our team is kind of surprisingly diverse and kind of in terms of the background, and it kind of relates to the kind of skills you need to have in place to be able to manage an environment like ours. We have people who were on the ops team who were developers in the past, people who were network engineers, people who were support, people who were working in system administration and DevOps. All of these folks have brought kind of their unique experience and perspective to come to bear on managing a fairly large scale Kubernetes deployment. We in our monitoring systems ingest terabytes of data a day. We have a logging stack that needs to stay up and scale as we add different use cases that we also built and monitor ourselves. So I think we have a great mix of people from with strong programming backgrounds. That's a prerequisite for any role in the DevOps organization. We have strong Kubernetes experience. We have CKAs. We have folks who are very technical and have either at Platform 9 or previously built up a good notion of not just how putting together a Kubernetes environment, but also doing it right. A big plus that we have on the team is everybody has strong opinions on doing the right thing so that you don't solve the problem of today, but the problem of 6 months from now when usage is twice what you anticipated. And that's the kind of team you need to maintain a complex and heterogeneous environment like ours.
So let's talk about the environment a little bit. Do you have multiple Kubernetes clusters that the DevOps team is managing today? Do you have a dev, test, and production? Are they one cluster, or do you have them separated into multiple clusters? Do you have multiple versions of Kubernetes? Talk about that a little bit.
Yes. So one of the challenges and actually internally one of the frequent sources of debate is this tension between how many do we want to have lots of isolated environments that we can independently support, so something goes bad in one place, it doesn't impact other use cases, or do we want to have a few but well maintained clusters? And especially if you're on a journey towards Kubernetes rather than starting from scratch, and you don't have a plan in place, it's very easy to see the sprawl of infrastructure where you have, the dev test production, or dev stage production categorization is an important one and should exist and does exist in our environment for every use case. But there's an important problem to be solved in terms of the number of environments. And in our experience, it's sometimes hard as an operations team to control how many of these environments pop up and suddenly turn into production, because Kubernetes does do a great job of empowering people to be able to build and deploy infrastructure for or build and deploy applications without worrying too much about the infrastructure. And as an operations team, we've taken a concerted effort to simplify some of that. There's in our experience, unless there is a strong driver for isolating different production environments, you want to have as few environments as possible that are production, and you made sure that there's a pager system, that there's runbooks, there's automation to manage that production environment really well, and obviously have staging and dev. So in terms of how it works at Platform 9, for most use cases, we have a CI/CD process where we have our continuous integration that is running tests and building images and deploying, typically for most of our Kubernetes use cases, to a dev environment, or in some cases a staging environment that we use for all of our ops tooling, for example. All of that has a CI/CD process in place that takes it to a staging environment. For production too, we have staging and production. We tend to we upgrade our staging environments very frequently. I think this is an important part of making sure that you have high confidence in the software that you're shipping to customers. The more frequently you can deploy, the more reliably you can deploy software. The more time you have to shake out issues that you hadn't anticipated in testing, and obviously add the testing that you need once you find these problems. But we upgrade our staging environment weekly. Our goal is to upgrade it daily. For our newer production use cases, we try to upgrade production once code has been baked in staging for a week. For some of our enterprise customers, obviously we can't do that just because there's a whole process behind it. But
Nathan, let me check in real quick.
yes.
So we have multiple development environments. When I say environment, I'm not talking about a namespace, but actually discrete Kubernetes clusters.
Yes, we do.
And do we have multiple staging environments as well?
Yes, and for the most part, they're divided by use cases. So we have, our free tier offering, which is a unique product that we have. We have our enterprise product and a couple of others that we work with partners on. And each of those environments, there is a each of them have a different cadence for receiving software updates, and we manage multiple dev test or dev stage and prod environments for those.
So when you say
just one additional thing is,
yeah,
we have a similar flow for operations tooling and services too.
Great. Let's jump on that in a minute. When you say upgrading an environment, do you mean upgrading the applications and services that are deployed, or are you talking about actually upgrading Kubernetes?
We upgrade the software side of things far more frequently than we would upgrade the infrastructure. It's just the nature of how we do things, but or how things typically work. We do try to keep up to date as far as the infrastructure goes, because it's kind of convenient that we dog food our own product, and when we push a release out to our management plane that has a new Kubernetes version, we use that, we leverage that opportunity to upgrade our Kubernetes environments on each of these.
Does your dev environments get upgraded on Kubernetes first and then staging? So you might have 119 in dev, 118 in staging, and 117 in production. Is that sort of how it works, or is it more consistent than that?
I think dev and staging tend to be, well, it depends on the timing of the release. So there's various factors in there, but I think when you're early on in a release, dev and staging will be a lot more in sync, and then once the release is out, then staging and production, while we're in the stabilization phase, staging and production stay more in sync. But yes, we try not to keep more than say two active versions.
And in Dev, is it your SREs and your team only having access to that, or is it the Platform 9 engineering teams that have access to the dev environments?
So the dev environment, so we have different degrees of restriction that narrow as you go up to production. But in dev, most engineers have some level of access for debugging build failures or troubleshooting infrastructure issues that come up. We definitely one thing we do is try to control that access very carefully, in the sense that if someone leaves the company, we make sure to turn that access off. But dev is definitely a lot more loose in terms of access control, but still scope to engineering. And then when you get to staging, it's primarily operations that has access to the environment, but dev folks have the ability to get in there when there's something particularly hairy or needs intense. But staging tends to be, we while it's not production, we try to keep staging pretty stable, because it is internal production, in the sense that if somebody does something that breaks staging, that's an internal production stall, and we try to avoid that by being a little careful about staging. And then production obviously is primarily operations and support in terms of access.
Okay. And when it's time to upgrade a Kubernetes cluster, do you sandbox it, then do dev, and then do staging? And then how does that upgrade work? Who gets involved? What's the process? I mean, these are all common day 2 operations tasks that anybody that's going to deploy Kubernetes, they're going to do this at some point. And have you had failures? What does that look like?
Not fun, but we definitely, within each dev environment, or within each use case, whether it's take operations tooling, we have dev, staging, and prod, and we upgrade in that order. I definitely think we had more issues in the a couple of years ago than we do today when it comes to these upgrades. Some of it comes with just experience and knowing what to anticipate, and kind of being better about the precautions that you take when upgrading. But for the most part, we follow that process, and our monitoring and alerting will tell us when there's a problem. So having that in place is crucial. But for the most part, it's the process itself is simplified to a single click, and then we have seen failures in the past where, particularly when related to persistent storage. But
let's talk about that. You said you had an outage related to persistent storage. Was it on your dev environment? Did it all the way go through production? And then what did it look? How did it manifest itself to the ops team? How long did it take? Tell us a story about that particular outage.
I think it was a while back, so I probably don't remember much of the detail, but it was at a time when we managed these upgrades very carefully. So we use our product and to do the Kubernetes upgrade, and there's, when we ship a new release of our software that has a new Kubernetes version, we just click the button to upgrade the cluster, and then watch. And then we have today we would more likely than not just click the button and then wait to see watch for alerts. But early on we would watch and make sure that each of the nodes were being upgraded properly in a rolling fashion. And then when we saw failures, we basically saw services losing access to their persistent storage and going into a crash loop back off state. We were again, it goes back to the expertise on the team that we had people who could resolve those issues pretty easily. But it's definitely a heart in your mouth moment when you start seeing things not come up.
Yeah, I remember one of our outages. This was several years back as we were developing our free tier offering and working in Kubernetes. So that our free tier, just a public note, go to platform9.com. You can sign up for our free tier offering, get an experience of what running a Kubernetes cluster underneath Platform 9 looks like. I encourage everybody to do that. But that offering runs in a Kubernetes cluster, right? So when you sign up, you get your own environment, your own set of pods inside of that environment, right? And I remember an outage that happened. It was pretty gnarly, I think, and it lasted for several weeks for us. I don't think it hit production, but I do think it was something that was concerning for our teams. And the way this manifested itself was we had worker nodes that would go offline. So our kind of knee-jerk reaction to that was, well, let's take let's kubectl get nodes. Yes, worker nodes offline. And we realized that our applications were failing, API errors were happening to our applications. Things were happening bad for the application that we were deploying. And then what we realized is, well, let's SSH to the box, the worker node, and see what's going on there. When we tried that, we couldn't SSH in, right? It was a problem. There was no connectivity to that box. So we ended up, restarting the box, and it came back online, and then pods got rescheduled and that sort of thing. But our reaction is to, first of all, we needed to do better monitoring, right? We learned that, we need to look at metrics more granularly on some of our applications. And then other applications, we had a kind of a generic monitoring set for that. And then we also realized that we needed to set limits and reservations for CPUs on the worker nodes, so that those particular worker nodes, regardless of what's happening with Kubernetes and the apps running inside of there, it wouldn't consume all the resources in the box. We reserved CPU and memory for the OS. That helped us SSH into the boxes. We then we also did a admission controller, right, where we set default requests and limits on memory and CPU for all the pods we deployed, and some of them we set custom ones for. And so we're getting better at scheduling pods on there, right? But what was happening is, and our engineering team was getting involved. It was Gotham and his team. It was Rupak, our CTO, our Bick, our chief architect, and many others, trying to figure out what's going on. And then the work, it happened again. It continued to happen. Worker node would go offline. And then when that node goes offline, what would happen was, the pods that were on that node, Kubernetes says, oh, I need to have these things running somewhere, and it reschedules them. So now this is where we learned the logging lessons, right? We need to capture logs from pods, regardless of what server they're on, that sort of stuff. But as those pods rescheduled, our cluster's one worker node smaller. And then all of a sudden it happened again on a random other node where a worker node would go offline. And so then pods would get rescheduled, and we're debugging this thing, and it was super challenging. And one of the things that we realized was, digging into kubelet logs and starting to get into stuff, we were starting to see that kubelet was being turned off. The reason kubelet was being turned off was because of the pod lifecycle event generator, Plague, right, which was looking at the health of kubelet on the worker node and saying, hey, you're not keeping up with the requests, I'm shutting you down. And the reason that was happening is because we ended up having tens of thousands of IP tables rules inside of our worker nodes, and kubelets, kubeproxy, flannel, all these different components were in contention for those resources running on that box. So we had a lot of learnings as we came out of that experience.
Actually, it also reminded me, you mentioned tuning and configuration that we did to resource allocations and all of that. All of that tuning gets you out of the woods for the current outage, but the other learning for us is, well, we need to persist it when we update or modify the cluster. These need to be reapplied. How do you kind of store that? How do you make sure that current and new clusters come up with the same tuning, and you don't forget the lessons of the past? So that's another kind of consideration that came out of that particular outage.
Yeah. And anyway, we solved it. We got through it. We ended up implementing, I think it was IPVS that helped us. And we got through the problem. But, our monitoring wasn't right. It wasn't set tuned to the right level. Our logging wasn't right. Our pod policies weren't right. There were a lot of things that we learned as a day two operations kind of team, right? That we needed to do. And a lesson from, if you upgrade the Kubernetes cluster, how do we make sure it's consistent and persistent? Right, so that's interesting as well. So and from a team perspective, you have to have a vast amount of technical skills, Kubernetes, but you also have to have logging skills. If it's the EFK stack, it's Elastic, it's Kibana, it's Fluentbit. If it's monitoring, it might be Prometheus, and what metrics am I looking at, and how do I look at the health endpoints for apps, and how do I put view those in a dashboard, and then in Grafana, and then how do I alert my team, and what is important to alert on, that sort of thing. So lots and lots of stuff that we can from a team perspective. Kubernetes is just not just this little Kubernetes thing, but it's a whole ecosystem that goes around it, right? And I find our customers are struggling with that.
Yeah.
Any other things you'd like to highlight?
I think thinking about alerting and monitoring is very important. One of the things that you mentioned there is, well, what do you alert on? And that's crucial, because Kubernetes introduces so many different failure modes that you need to account for, and also handles a lot of things that typically would have triggered a page. So you have to kind of change your thinking to the new world. For example, if a hypervisor goes down in a virtualized world, you probably want all hands on deck and make sure that your workloads are rescheduled properly. And while obviously there's products that and tools that handle HA in virtualized environments, it's a lot less of an issue with our Kubernetes deployment. So we don't trigger a page when something like that happens. Our workloads get rescheduled. Nodes, we're able to run our workloads pretty comfortably on spot instances without needing to worry about the underlying hardware, and let Kubernetes handle that. And you need to make sure that you have alerts tuned to the point where you don't kind of fatigue your operations people with too many alerts. You want to make sure that you're capturing only things that are actionable, rather than, oh, here's an interesting thing that happened, you may want to look at it. That's not the kind of thing you want to wake up for at 2 a.m. for.
I think it's pretty amazing some of the things that you and your team have done, like to the nth level of detail is amazing to me. So, for example, an alert gets fired. It's generated from a Kubernetes cluster, right? It's generated from Prometheus running on that. It's displayed in a Grafana interface if somebody's watching that. We have Alert Manager configured where it fires an event. It could be an email, it could be a Slack message. I think what I've seen is a lot of our Slack messages that come into the environment. And then every one of those messages that comes in that has a Slack message has also a standard operating procedure, right? Yep. So your team have taken the time, you've got the experience where you've done this before so many times that, if a worker node goes offline, what do I do? And then you click the link and it gives you a Confluence wiki page, and it's step by step. here's how I troubleshoot this, right? And it might be a chart. We go down different paths, but eventually you'll get to where the problem is and be able to restore the service very quickly as a result of that. You want to talk about some of that?
Yeah, that's something that's when we started off with that effort, a lot of our procedures were in people's heads. Like, somebody just knew what to do by virtue of having been at the company for a while. And that's great. But, when you're woken up in the middle of the night or there's a fire, you want to make sure you front load all of your thinking to when things are calmer. So when all of the kind of, okay, these are the steps that you follow, were put together when reviewing past incidents, looking at new incidents as they happen. Those procedures got documented, and what that's allowed us is to take a lot of the kind of burden on an operations person. When they get an alert, they can go straight to a Slack channel where if they get it on their phone, they go straight to the Slack channel. They'll see a link to a dashboard that they can click through to see whether if it's an API error rate, has it been trending up or down? If it's a service that's gone down, is it back up? If it's still down or problematic, there's a runbook link that is very specific in terms of you see the symptom, do this. If you see this, to do this. If it's it's just a general set of procedures that you can go step by step, that is as easy to execute at 2 a.m. as it is at 10 in the morning. And that's really helped kind of because we're not a large company. We don't have an army of operations people and the knock and but we're able to get a really good level of uptime by making sure we have a really smart set of engineers and well-documented procedures.
Thanks, Gotham. So I'll switch a little bit to a little bit about Platform 9. I'll do 2 slides here. And all of Gotham's best practices and the things that all the lessons that he's learned in running in production, Kubernetes in production, is really transitioned back into our product, right? What Platform 9 does is we deliver what I consider rock solid production ready Kubernetes, right? So we simplify the decision of how to deploy Kubernetes, right? We deliver to you upstream Kubernetes straight from the GitHub repo, offered to you as a SaaS managed service, right? Our monitoring that Gotham's spoken quite a lot about, right? And our operations teams, you consider them as the guys who have your back in managing your Kubernetes clusters, right? We've been there, we've done that. We know what the outages look like. We know how to respond to them, right? And when you have a problem with a Kubernetes cluster that you're running under Platform 9's managed service, it's very simple for us to engage support, right? If it's a sub-zero event, we can jump on a Zoom with our engineering and your engineering teams, and we'll stay on that Zoom with our teams, and we'll escalate into Gotham's team. We'll escalate into some guys on my team on the solution architect side. We can escalate into engineering and pull in the right people to solve the problem to get your Kubernetes cluster back and up and online as quickly as possible. We've got the tooling in place for deployment, management, monitoring, maintenance, upgrades. In fact, I'd say that Platform 9's got one of the simplest zero-touch Kubernetes upgrades in the industry, right? What that means is you say, I want to upgrade this Kubernetes cluster. You go into your UI or you hit our API. You select the Kubernetes cluster you want to upgrade. You confirm it, and then you say go. And then once it launches, we start through a process where we upgrade for you on your Kubernetes cluster, one master node at a time. We cycle through each of those master nodes, upgrading. We take it offline. We record in the node. We move any pods that might be running on that environment. We upgrade it, then we uncord it and bring all the pods back online, and we cycle through to the next master node and the next master node. Right. Once all the master nodes are complete, then we start cycling through each and every one of the worker nodes until the upgrade is fully complete. Right. We manage Kubernetes clusters where you want to run them. Where you and your customers want to run their Kubernetes clusters. Is it Azure? Is it AWS? Is it Google? Bare metal in your local data center? Is it inside of VMs inside of your local data center? It doesn't matter. We can run Kubernetes clusters where you want to. We do have a financially backed SLA. We are part of the Kubernetes security SIG, where we get acknowledgements of what's happening inside of the Kubernetes project as far as security risks, and then we work with our engineering team or the community to come up with a patch. So on day 0, we can implement that. And we just completed our PCI compliance for our Kubernetes offering, so that's fabulous as well. Real quick, I think I highlighted a bunch of this already. We're going to run wherever you want to. VMs, data center, cloud providers, right? We can manage geographically dispersed Kubernetes clusters in our 5G edge offering, right? We have Kubernetes clusters running your cell phones, thousands of them across a geography, right? So we do that. We have virtualization. We have both our Platform 9 managed OpenStack and our Platform 9 managed Kubernetes. We can manage these things from the ground up too, right? So if you've got bare metal and you want to boot to an OS, have that OS boot into a Kubernetes cluster, all automated, right? Giving you that cloud-like experience in your local data center. You can potentially take our platform and do capacity on demand or cluster scaling in your local data center by leveraging our APIs and some of our capabilities you've got there, right? So our Kubernetes offering, we do offer load balancer as a service, right? So Metal LB, that's very useful in your deployment in your local data centers. In the cloud providers, you use ELBs and things like that. We come with options for observability. That includes Prometheus Alert Manager, Grafana. We've got Fluent D. You can turn that on deployment of a Kubernetes cluster. We've got advanced networking, right? So this is pretty cool operations for a pretty cool offering for us, right? What that means is you can deploy Calico or Flannel, right? But if you want to deploy our advanced networking stack, you could do that through our recently released Luigi operator. It's on our website under the 5G offerings. And what that does is it allows you to deploy Multis, SRIOV, DPDK, Open vSwitch, Mac VLAN, different CNIs that you might have a need to run inside of your Kubernetes cluster. Super easy to use. I think it's one of the most advanced things available there. We've got our app catalog. We've got Cool Kubernetes, which allows you to look at tutorials on how to do different things, right? CI/CD and ingress controllers and service mesh and all kinds of different stuff. We integrate, lastly, on the outside with, Okta, different SSO or SAML2 providers, so we can provide access straight into the Kubernetes cluster if you want to. And then we have great tooling around our CLI, Terraform, and that sort of stuff. So I guess, Kamesh, do we have questions?
Yeah, there are a couple of interesting questions there. So the first one has to do with the run book. I guess this is for Gautam. You mentioned their run books. The assumption there is most of these run books are automated to the extent possible. The question is around, are there also other semi-automatic or even manual procedures that you need to do, and what would they be?
So I think semi-automated is a good way to put it. Our general process tends to be, if there's a unique problem, then you debug and determine the resolution at that time, and then you document it and refine that documentation so that there's a standard set of steps. The next step is to automate it, and what that means is reduce kind of a set of procedures to a single command that you can run. And for the most part, that's kind of where we're at in our journey. The next, logical step is to eliminate the need for any procedures by automatically triggering those actions. But for the most part, what we've been focusing on is at least making sure that when there is a set of steps to resolve an issue, instead of well-known steps to resolve an issue, we try to change those to either build those into our existing tooling so that it doesn't, it eliminates kind of human errors.
So a good example of that might be if disk goes full, we can automate the response to that by automatically logging in and maybe looking at varlog pf9 directory and seeing, oh, we've got a ton of backups. We can clean up some immediate disk space by removing those zip files of our backup logs, right? So things like that can be automated.
Yep.
More complex things requires troubleshooting. Dinesh, are there more?
Yeah, there's a couple more. One is around, we talked a lot about Kubernetes and all the lifecycle management operations around it, but a typical production environment is much more than Kubernetes, right? You mentioned a lot of other tools for logging, for monitoring, for Cortex. And so the question is around maintaining some level of sanity in terms of the versions of all of these different products, and that's part of lifecycle management of an environment. How do you manage the different versions and the compatibility between them as you maintain these environments, complex environments with different tools? And what are some of the best practices around that?
So managing versions of tools and their compatibility with Kubernetes or between
Yeah.
themselves.
Yeah, I guess when you upgrade something, like for example, if you upgrade Kubernetes, then if that's not compatible with whatever else you have in the system, that can cause issues, correct? I think that's kind of
So
what the question is about. Yeah.
Gotham, I think what they're talking about is you upgrade Kubernetes, but this upgraded version of Kubernetes requires a new version of Docker or a new release of etcd. How do we handle that?
Yeah, exactly.
So we generally it depends. Some things you have to upgrade together, and there's not much you can do there. And usually, unanticipated version incompatibilities are shaken out during our dev phase. But when it comes to managing software on, for example, if you are making sure that our logging system is consistent, or we have to manage other configuration. We use configuration management system for that. We for kind of out of band or for managing compatibility outside of our software. So we use SaltStack pretty heavily to manage configuration. For example, we have console and vault deployments to make sure that that software is manageable through a centralized system. We also, for example, we're upgrading our version of Cortex actively, and we follow the same procedure when it comes to tooling as we do with our production Kubernetes software. We're upgrading our dev environment, making sure it's right, and it's important to mirror dev and production in terms of usage too. So we have the same kinds of metrics collected from our dev environments that we do from our prod environments, and we're able to shake out incompatibilities and issues there and manage configuration that way.
Great, thank you. I think we're just about 2 minutes left in the webinar. There's one more question we can take, and this has to do with PCI compliance. Anyway, they say it's a great webinar and content. Thank you very much. Regarding the PCI topic, can the same concepts apply for other compliance, such as HIPAA or SOX or what have you? I don't know if we know the answer to this, but
so
I'll throw it out there.
We just went through our PCI SAQD audit, and that will serve as the foundation for our SOC 2 certification that we want to tackle. I think there is a order in which you can go such that you can get the one set of certifications easier than the next. But I think the PCI SAQD sets you up well for something like a SOC 2, but once you get into HIPAA or the FedRAMP standards, there's a whole lot more that's involved and unique to each standard. So I think there are a few that you could probably target early, but then stuff like HIPAA and FedRAMP get far more complex. So they'll bring their own unique challenges and costs typically with those.
All right. Thanks, Gautam. We're almost out of time. Actually, we're out of time. So I'd like to now announce the winner of our drawing here. The lucky winner doesn't look like he's on, but his name is Sachin Joshi. He's an enterprise architect at Verizon. So congratulations for winning the prize. We will get in touch with you and get you your prize shortly. So thank you very much, everyone, for joining us live today. And thanks again to our presenters and especially to Gautam for being our special guest today. Lots of great insights. Thank you very much. And you will get an email with the recorded version. So don't worry if you miss something. You can always go back and check the recording. Thanks, everyone. And we look forward to seeing you in the next webinar. Take care. Have a great day.